All right. Happy. Look, the thing in the middle of the screen is missing. I love that. This is the first time it's disappeared all on its own. All right. Welcome to Thursday of week 6. I'm so excited. Tonight's some super important stuff, and it may not look like much, but it's a really important topic. So we're going to spend enough time on it that I'm hoping you grasp it and you're like, yeah, this makes sense, and you will have enough to do the homework. And since not everybody that watches the video makes it all the way to the end, I want to remind you. So the test opens on Tuesday. It will cover chapters 5, 6, and 7. So it's going to open on Tuesday at 5 a.m. and close on Thursday at 11:59 p.m. On Tuesday, we will have office hours, just like we did last time on the first day of the test. We will have office hours, so there will be no new material. It's just going to be office hours from 5:30 to 6:30. You can pop in, ask your questions, ask questions about the test review, about homework assignments, things like that. So feel free to pop on in and ask those questions on Tuesday. And I've started giving feedback on the project proposals, but I haven't made it very far yet. So I'll be working on that. Um, be working on that probably mostly tomorrow and Saturday, because tomorrow I do have 5 of my grandkids over and we're going to be working on Valentine crafts. So it's going to be loads of fun, but maybe while they nap, I'll work on those a little bit. So don't fret. I'll get those done as quickly as I can. I also haven't even started grading the hand in homework yet. So that's why that doesn't have a grade on it yet, because I have not even started that. I'm going to try to do the project proposals before I do the hand in homework, because I want to give you plenty of time to work on collecting your data and reading the feedback and all that. So, and once a grade pops up on your project proposal, you know there's feedback. So as long as it's showing 0, I have not given you feedback yet. So as soon as that grade shows up on there, you know that you have feedback on there. So that's when you can click on it and go in for the feedback. All right. So today we're going to do section 7.2. We're going to look at the area under the normal curve, and we're going to talk about what that means. We've already kind of done that, but we're going to do it a little bit more formally. And then we're going to talk about a fancy calculator function that's going to help you to find your probability or proportion of things under the mean. So find the things that are not the empirical rule, all of the other numbers, the like 68 or 62% or 13.5% or whatever, all of those numbers, the real numbers that are not just part of the empirical rule. So I'm going to show you how to find those. We're going to have a couple new tools, some calculator functions, and something that we call a Z table or table 5. Show you how to use that. So it's not actually necessary to use the Z table, but it's a good tool. And so I'm going to show you how to use it. So that's where we are tonight. And it's still not going to be a super long class, but it's going to be a little bit longer than Tuesday. But Tuesday was like short. So, all right. So here we go. So um, we saw it when we were looking at comparing like the heights of 2 basketball players, or we were comparing the number of runs for a baseball season for American League versus National League. And when we're or ACT and SAT on, oh, wait, you haven't done that yet, but that'll be the SAT and the ACT question on your next homework. Comparing 2 things that are not exactly the same, 2 populations that have different means and standard deviations, but you want to compare them. Frequently in math, we do things where we put them in the same units. So for example, if I was comparing 25 miles to 25 meters, it's or 25 kilometers, it's hard to compare those things because the units are different. So we try to convert them to the same unit so it's easier to compare. So that's the same thing with standardizing a normal random variable. So when we take any of our variables and we convert it to a z-score, then we're using basically common units. So we can standardize our variables by converting them all to z-scores. So when we have something that is normally distributed, if we convert all of our data to z-scores, we will have a mean of 0. Circle this. We'll have a mean of 0 and a standard deviation of 1. So when we convert to z-scores or convert to the standard distribution, it is going to have a mean of 0 and a standard deviation of 1, and we will be using z-scores rather than the actual data. So all of our data has been converted to z-scores. It's not as much work as you think it is. It's all right. Oh, whoops. Let's flip things around. Okay. So let's talk a little bit about this. Let's do our z-scores again. We've done this before, but we're just going to kind of brush up. IQ can be modeled with a normal distribution. It has a mean of 100 and a standard deviation of 15. So if I take an IQ score of 120, it is going to have a z-score of 1.33. That means it's 1.33 standard deviations above the mean. So we just take the data value minus the mean and divide it by the standard deviation. This is not brand new information. So in your Z table, I'm going to show you where to find this. So if you are in the, I'll go to student preview. If we're in Blackboard, I have two different places that I've put Z-scores. So I put one all by itself right here, our Z and T table right there. And I think, I'm trying to remember which week. Did I put in week 6? I believe it's in week 6. It's at the top of week 6. I put it in both places because we're going to continue to use these in later weeks, but I wanted you to be able to find it in your week 6 materials as well. So you have it in both of these places. It's a really good idea to print it out. So if you want to use it on your test, go ahead and print it out. It's a useful tool. So go ahead and do that. So this is my Z table. The one on the PowerPoints look a little bit different. Oh, see, now this thing popped back up again. So rude. Move it over there. Okay. So the way that we use a Z table, so the Z table, it's also called table 5 or table V, which is table 5. So if I'm looking at, I'm going to draw this curve first. I'm going to draw this curve. So at the mean, it has a z-score of 0. Once I'm 1.33 standard deviations above the mean, it's going to land somewhere right here, or 1.33 standard deviations, or z-score. So this would be a z-score of 1.33. So it's more than 1 standard deviation above the mean, but not quite 2. So the way that we can find this area right here, the area from that z-score and less, I'm looking for this area that is less than or equal to that z-score. So this table, our Z table, gives you the area that is to the left, that's less than or equal to that. So I go down to, on the left column, it gives me the whole number and the tenths place. So I go down here to the whole number of 1.3, and so the whole number of 1 and the tenths place of 3. My column gives me the hundredths place. So I have the 0.03 here. So this right here gives me the area under that curve. So the area is 0.9082. So if I if I randomly chose somebody, randomly chose an individual, there's a 90.82% chance that they would have an IQ that has a z-score of 1.33 or an IQ of 120. So this gives me that area. This is a way to do it without the calculator. We just use this Z table and it's really cool and I love it. I'm going to show you on our Z table. Uh-oh. I'm swiping on the wrong thing. So our Z table, let's make it bigger. Once again, the hundredths are up here. My whole numbers and my tenths are here. This diagram reminds us that this gives us the area to the left. So I'm going to go to 1.3 and then wait, that's 0.3, 1.3, and this is 1.30, 1.31, 1.32, and there's 1.33 right there. because that's the column with the 3 column. So right down here, there's my 0.9082. Remember, this gives you the area to the left. If I was looking for the area to the right, and this is going to come up on a future slide, but this fits really well here. If I was looking for this area instead, the yellow, I would just have to do 1 minus. I would have to do 1 minus 0.9082 to get the area to the right. Because kind of like with binom CDF, it only does less than or equal to. It doesn't do greater than.
Okay, so can you clarify something right there? So the 1.33 is to the right. So do you mean to the right of that,
The
or
1.33 is the z-score. The 1.33 is this point, this spot right here on my normal curve.
okay?
This
And
is
so
the
anything to the right of that is going to be on this table, or
no,
anything to the left of that is going to be on
anything
this
to the
table.
left, the
Okay.
left. So what this is saying is the area under the curve to the left of 1.33 is 0.9082. So less than or equal to 1.33 is 9 is so basically, okay, so let's say that I have an IQ of 120. I calculated the z-score and I got 1.33. So what this is saying is that my IQ of 120 is basically at the 90.82 percentile, which means that 90.82% of all human beings will have an IQ less than or equal to mine of 120. Does that help?
Yes, thank you.
Good. All right. Moving on. Okay, so my drawing was so much better than this. This is, very rudimentary drawing of the normal curve because mine was so much better. So as I said that we would do 1 minus if we want the area to the right of that spot. This kind of shows, there's the 1.22. This is or 120. This is my z-score of 1.33. So in order to use that table, we have to use z-scores, and this standardizes it. So this makes it so that we can use that tool of that Z table. Because obviously I'd have to have a separate table of every single data set that ever exists in the world if I was using regular numbers rather than Z-scores. But Z-scores brings it all down to the same units.
In future questions, is the standard deviation and the mean provided, or is that?
Most of the time, yeah. I mean, there'll be occasion when you have to calculate them, but most of the time I'm gonna give them to you. And I believe they're given to you in your homework and everything. But for example, if you were using these things with your own data sets in your final projects, you're going to be calculating your own mean and standard deviation. Ouch. Why'd you attack me?
Okay, thank you.
Yeah. She just came up and just grabbed me with her claws. I'm sorry. All right. So we have math, we have fun calculator functions. So the calculator function that we use for to find that area, if we don't want to use our z-score, is we can use something called normal CDF. I'm going to show you how to use it in a minute. We use something called normal CDF. We never use normal PDF. There's never a case where we will use PDF. Never a case. Always normal CDF. Always, always, always. It is a cumulative function, but we're looking for the area under the curve. The nice thing about normal CDF using this instead is this can give me to the left or to the right. So basically the way we use normal CDF, and I'm going to write an all-encompassing here, and then I'm going to show you how to use it and explain everything. So with normal CDF, also the nice thing about the normal CDF is you can use it with data values. It doesn't have to be z-scores. So the normal CDF, you put your lower bound, you give your upper bound, and I wish I would have moved this to the left. I'm going to do it. I'm going to move it over. Thankfully, I can do that. Then I'm going to use my mean, and then the standard deviation. So whatever area of the curve I want to find the area of, let's pretend it's this lovely area right here. Say I wanted to find the area here. I would put whatever the data value is of my lower bound in the first spot. Then I'd put whatever the data value of my upper bound in the upper spot. And then I'm going to have some mean and some standard deviation that I'm given or that I calculated. And we put that in there and it's going to give me that area, which gives me basically the probability of landing in that area or the proportion of the population that lands in that area. This right here, and I'm going to show you how to use it, is our way of putting infinity, negative infinity into our calculator. That's how we put negative infinity into our calculator. I'm going to show you with this example right here how this works. So this example says, what is the probability of getting a z-score less than negative 1.2? So we're looking for a z-score less than negative 1.2. So go ahead and grab your fancy schmancy. Okay. So do second, make this bigger. Do second vars, because we're going to the distribution screen. This is the same screen we use for the binomial CDF. We're using the second option because, as I said, we never use normal PDF. Never. I mean, there are cases in the world where you will use it, but in our class, we will never ever use normal CDF. So our normal PDF. We always use normal CDF. So once you go into that, it's going to say lower bound. I'm going to clear this out so I can show you how to do it. Negative 1E99. So I'm going to go back real quick. What this means, and you've probably seen something like this in your calculator. This right here, this right here is scientific notation, the way it looks in our calculator. So what negative 1E99 is, negative 1 times 10 to the 99th power. That's what that is. So it's negative 1 with 99 zeros behind it. So it's basically negative infinity. So if I have 1E99, this is positive infinity. This is 1 times 10 to the 99th power. This is the way scientific notation looks in your calculator. Occasionally, for a probability in your calculator, you're going to see something like 2.58 E negative 6. You'll see something like this in your calculator. You may have already seen something like this in your calculator. What this means, it's scientific notation, means 2.58 times 10 to the negative 6th power.
So the E just means times 10?
Yes, times 10 to the that power. This is an exponent.
Oh, it just doesn't write it as a little exponent in the calculator.
Yeah. So
Okay.
this is the exponent of 10. So what this means, if I was to write this as a number, I'm going to delete some of my things here because I'm running out of room. If I was to write this as a number, all you're doing is moving the decimal, move decimal that way 6 times. So I'm just taking this decimal point and I'm moving it 6 times. So what this number is, this equals this. Because I just took that decimal point and I just moved it left 6 times. But if your calculator has something like this, it's going to give it to you like this. So, because you can't have a probability of 2.58, but I can have a probability of 0.000000258. So just try to be mindful of that. This is something that pops up every year where someone struggles with this. And if you forget and you need to ask me about it again, just do it. Just ask me about it again. If you end up with a probability that's weird, Just tell me what your calculator says. Send me a message. Tell me what your calculator says, and I'll help you out. Because scientific notation is something that sometimes we forget about. Okay, I'm going to pop back to the calculator. So our lower bound is going to be negative 1e99 because what I'm looking for is less than negative 1.2. So off to the left to negative infinity. If I'm doing less than, we go to negative infinity. So it's negative 1. So your negative button is right here, negative 1. Our E is not the E that's by sign. That's not it. It is this right here where the comma is. See the two capital E's? That is the E we're looking at. So do second comma. That gives me this little capital E right here, and then just 99. That's how we put in the scientific notation that we need for our negative infinity.
But and for the negative, did you just use the
You
which-
use this right here.
Okay, great.
If you use the minus, it's going to give you an error. Most common mistake is to use the minus instead of the negative. This right here, next to the decimal, that's the negative. It's just, and I don't know why they put it in parentheses. I think that's really strange, but it just is. It's what they do. And sometimes we just nod our head and smile and be like, okay, yeah, whatever. Okay.
So whatever, sorry, so whatever the first number is, so this, in this case, we're doing less than negative 1. So if it was positive 1, you wouldn't do the that, yeah.
So if it's less than, it's always going to be negative 1e99 on our lower. If it's greater than, then our upper will be 1e99. We're going to do one of those in a little bit, so you'll see. But if it's less than, every time it's less than, we use negative 1e99.
On any equation.
Anytime we're using normal CDF, yes. If it's less than, use negative 1e99.
Thank you.
And less than or equal to do not mean anything different on these. So you don't have to worry about, oh, this one says less than or equal to. They're exactly the same thing on normal CDF. So no confusion there. They're exactly the same. So my upper, we're looking for what's the probability or what's the, what is that area less than negative 1.2. So once again, use this negative 1.2. That's my upper bound, because it's less than negative 1.2. So this is as high as I go, and it's z-score. So every time we are doing probability with z-scores, my mean is 0, standard deviation is 1 every time. If you're using z-scores, the mean is 0, standard deviation is 1. This is one of the beautiful things about standardizing the normal curve, is that we end up with the mean of 0 and the standard deviation of 1. Okay. And I'm going to hit enter. This shows what it looks like. So if you have a TI-83 or your TI-84 doesn't give you that other screen, this is what it looks like. Okay. If you're once you're taking your test next week, if you use the normal CDF function to find a probability, write this down in your work. This is what you're going to show for your work. Show me what you put into normal CDF. That's plenty of work. Because if you show me that this is what you put in, and then maybe you give me a wrong answer, I'm going to be like, they must have typoed. Because I see their work is exactly correct. They must have typoed, and I'll probably only take off half a point. Whereas if you don't show me this and you just have the wrong answer, you're going to lose all the points. So give me this work. And then there's our probability, which matches what the notes said. Go back over here. And so it gives it right here. I usually go to 4 decimal places on probabilities because I like turning them into percents. But if I don't tell you what to round to, I don't care what you round to. My open math, on the other hand, they're a pain in the rear, but you know, it's free. We got to remind ourselves it was free. Every time I have issues with my open math, I just remind myself that it was free.
So would you say no matter what, as long as we're using the normal PD or CDF, we should absolutely have this, use it with z-score?
No, I'm not.
No.
I'm not saying that. I'm just saying that this is a simplified way. This is the nice thing about normal CDF. If you're using the Z table, yes, you have to use Z-scores. But if you're using the normal CDF, you can use data values, and we're going to do that in a minute.
Okay.
Yeah. So this is the lovely thing about this is you don't have to convert everything to Z-scores, but it is a nice way that if I was comparing two populations, I'm going to use Z-scores. Okay. And actually, let's just do that with this right here, right now. Let's go back here. Okay. Okay. So let's do this back here with this. So we're looking for the Z-score, or I'll do it here since I have the picture. So I'm looking for the area to the left of an IQ of 120. My standard deviation, my mean is 100, and my standard deviation is 15. And I'm looking for the probability that my variable is less than 120. My IQ is less than 120. Okay, so let's jump to, actually, I'm going to write it down first. So I'm going to use normal CDF. My lower is still going to be negative 1E99 because I'm using less than. My upper is 120. My mean is 100. My standard deviation is 15. This is what we're putting in our calculator. And it's possible it'll be slightly off because because Z-scores are rounded. So my answer could be slightly off. It happens. Usually my open math is will take either answer, either what you did with your normal CDF or what you did with your Z-score. Occasionally it messes up. That's why chapter 7 is weird in my open math. So let's jump to the calculator. So I'm going to do second vars, go to normal CDF. I still have 1A99 in there. I'm just going to leave it in there. 120 for that. I have a mean of 100, standard deviation of 15. So don't forget to change those. They're no longer 0 and 1. We're using actual data values instead of Z-scores. This is what it looks like when it comes out, when you write your, or if you don't have this fancy calculator. And I hit enter. So they gave us 9082. This one is 9089. And it's because the calculator doesn't round. Because the calculator's not rounding. Because if I'm calculating the Z-score of the 120, it's going to look like this. Let me see. 120 minus 100. Well, let's try this again. Having issues. 120. I don't know why I'm having issues. 120 minus 100 divided by my standard deviation of 15. So see, when they got their standard deviation, they rounded, which makes, their Z-score, they rounded to 1.33, whereas the actual Z-score is 1.3 repeating. Because of this, you end up with a slightly different answer using the Z-score, just the Z-score. But our calculators don't round, they keep the whole number in there, and it's fine. My open math should be correct either way. Okay. All right. Let's move on. If I'm using the Z table, as we said before, use the complement rule if you want the area to the right. But if we were just using your calculator, we can do it the other way. So let's take a look. So I'm going to look for greater than. So I want to find what probability, percentage, proportion, whatever is greater than 1.3. So I'm looking for the probability of getting a Z-score greater than 1.3. So we already kind of looked at this. So this is going to be 1.30. So it's going to be this right here. But because we're looking for the right of, I would do 1 minus 0.9032, which is, uh-oh, my calculator's doing something weird. 1 minus 0.9032. So it would be 0.0968. So if I was looking at, so here's my z-score of 1.3, and I'm looking for this area up here. I had to do the 1 minus. I had to do the complement rule. You don't have to do that with normal CDF. And I'm going to show you. I know I'm moving fast. I'm sorry. I get excited when I really enjoy the math. Sometimes I get excited and I move too fast. If I'm doing that, just shut me down, slow me down, whatever. And plus I did have too much caffeine today. So that's a thing too. Okay. So I'm going to do second VARs again. Go into normal CDF. My lower bound is 1.3 because we're looking for z-scores greater than 1.3. My upper bound is going to be 1 second comma E 99. This is my positive infinity. So 1 E 99 is my positive infinity. And then once again, my mean is 0 and standard deviation is 1 because we're dealing with z-scores. And then I hit enter. This is what it looks like on this screen. And I got, it's exactly the same. We had 0.96 or 0.0968. That's the same thing that I got when I used the Z table. Because there was no rounding involved here. This was nice and pretty.
Melissa, can you remind me? I think I missed it. How you get the E in there?
It's second comma gives me that E. So look at, see, it shows an E here.
Got it. Thank
But
you.
yeah, that's the special E. Because there's this other one right here, and it's not going to do you any good. The one above sign, it's not going to do you any good. My high schoolers use it for typing weird messages to people in other classes on their calculator. They will do things like, yeah, they write weird stuff in there. It's real pointless, but high schoolers. All right. So are we okay so far? Any other questions so far? Moving right along. Feeling okay? Feeling groovy?
Why does the Z have a subscript of 0 at the top?
Because this is just saying probability our Z-score is greater than whatever Z they choose. So
Okay.
it's just a way of differentiating this Z and this Z.
Okay. So it's like almost like a variable X.
Kind of, yeah. Yeah.
Okay.
So it's like what's the probability this Z-score is greater than some number Z?
Okay.
Basically. Yeah. I wish there was a deeper meaning. Okay. So
Wait, can you hold on? I was writing while you were doing that stuff. I fell behind. For the upper limit, you put 1 on that last problem you just did. You put 1E99 in the upper limit section on the calculator.
yeah, let me go in there. I just saw you just saw it on the chat. So yeah. So my lower is 1.3 because we're going greater than. This is my lower bound. My upper bound is 1E99. We're dealing with Z scores. So it's 0 and 1.
Okay, thank you.
Huh? Okay. So y'all got this. Once you start doing the work, it's not that complicated. I am going to jump into my open math though, and I will talk about a couple different homework problems that people tend to struggle with. So I'll do that. I think that you're going to get this better than you think you're going to get this. So try not to stress out. You're going to get this better than you think get this. You're going to be okay. You're going to be okay. All right. So, I'm looking for the area between two Z-scores. So I'm going to draw, this is not the pen. I'm going to draw my lovely curve. I know you guys look forward to me drawing my curves more than anything all week. You're like, I sure hope Melissa draws more curves. It's because they're just works of art. You're going to be okay. Don't panic. Please don't panic. Okay. So this Z-score, whoa, I just erased everything. Good. That means I get to draw another one. All right. So this Z-score right here, negative 1.02. This Z-score up here, this is 2.94. and I want the area between them. Remember back in the old days when we did our we're using the empirical rule, you would just add up all the probabilities in between. This is even easier than that. You totally got this. Totally got this. So once again, we're going to use normal CDF. My lower bound is negative 1.02. My upper bound is 2.94.
But how do you know that you're doing, oh wait, you're just putting in, you're not even doing the 1E99 because you have the Z-scores?
Right. Yeah, because I have this is the lower bound right here. This is my
Oh, okay, because you're not going any further. It's literally just showing, okay,
Yeah.
okay.
And then this is my upper bound. No, this is great. Thank you for saying that. I'm sure somebody else was wondering what the heck was going on. So perfect. Okay, so that's my lower bound and that's my upper bound right there. So basically I'm looking for the probability that negative 1.02 is less than Z, which is less than 2.94. I'm looking for the probability it's in between those two values. All right. So, and my mean is 0, and my standard deviation is 1. So I'm looking for this region in between those two values. So therefore I can do that. There's a way to do it with the Z table, and I'm going to kind of talk about it, but I don't recommend it. So I will kind of mention it, and if you don't want information overload, just block me out, but I'll kind of mention it in a minute. First, we're going to use normal CDF.
Wait,
Yes.
I have a question.
Yes.
So for that formula, when you use the 0 and the 1, you do that when you do have the Z-scores already?
Yes, this is only for Z-scores.
Okay, and that's why on that other one, on like when we did the negative 1 E99, we had random numbers, or well, not random, but we didn't use the 0 and the 1
when we
because
were
they
using
weren't Z-scores.
when we're using actual data values, you use their mean and standard deviation. But
Okay.
when you're using Z-scores, you use the 0 and the 1.
Okay, that makes a lot more sense. Thank you.
Okay, I'm going to jump to the calculator again. I'm already on this screen. So my lower Z-score was negative 1.02. My upper Z-score was 2.94. My mean and standard deviation, these are Z-scores, so we're sticking with 0 and 1. And this is what it's going to look like on my screen. And hit enter. Is this what y'all got? This is what y'all got? Good. Yay! So are we less panicking now? Are we feeling a little bit better?
Do we still round with this or do we do exact what it gives you?
I would probably do 0.8445 is probably what I would write down. I'm going to write that on my screen right now before I switch over. So I'm going to say equals or approximately 0.8445. Yeah. So that's the probability. So the probability that something, a randomly selected object or whatever, landing in between those two values, those two Z-scores, is about 84.45%. Well, thankfully we didn't do math at the last class. It was all interpreting things. So hopefully you can pick it up and you'll be okay. But definitely go back and watch the video. It was a short one. It wasn't even a very long video. All right. Okay. So if we're using but these are the two ways that we can do it. You can either use Z-scores and go to the lovely Z table, which I mean, the Z table is kind of cool. And I mean, I love like it. This is like old school stuff. This is like typing on a typewriter instead of typing into a Word document. That's kind of the way you can look at things. It's like using the Z table is like pulling out your old-fashioned typewriter and typing on it. And when I was in high school, way back in the 80s, yes, I'm that old, I was in high school way back in the 80s. We didn't have fancy schmancies, so we had to use things like Z tables. And there was no other way to do it. That was the way we did it. And I'm going to kind of real quick talk about how we would do a between two values with our Z scores, but you don't ever have to do it. So I'm just going to kind of give you an idea. So
Okay.
yes,
Really quickly. So you can either use the Z table or you can use the normal CDF.
correct.
One or the other. Or you can use whatever. Okay, thank you.
Yeah. The Z table is you don't have to use. You remember the Z table from high school? Yay! Yes. So, I mean, that's the thing is when I was in high school, we in the back of the book we had logarithm tables, we had the sine, cosine, and tangent tables, we had Z tables, we had all of this stuff. Everything was in tables in the back of the book. We all of our calculators were like those cheapy little like 4-function calculators. We didn't have nice stuff. And it's probably better anyway. I mean, we're Gen X, we're all whatever. But anyway, so going back to the other screen. Okay, so the way that I would do this with a Z table. So the way that we would do this with a Z table is if I was finding between two things, I'm gonna draw my own because we all like mine better anyway. So if I was looking to get between these two Z scores, I'm going to do Z sub 1 and Z sub 2. I want to get this right here. This will be reminiscent of what we did with the binom stuff. If I was going to use the Z table, I would find this Z score on the probability of the upper value. I'm going to find the probability of this one right here on my Z score, my Z table. It's going to give me all of this, the whole thing right there. Okay. Then find the probability of this one right here. Because that's going to give me, how come I don't have very many things here? That's going to give me, I want to put this right here, just this right here. And I'm sure you see where I'm going. So you take the first one, this Z2 area, and you're going to subtract this Z1 area. So you're subtracting, this is really ugly. I'm making everything really ugly. So what I'm doing is finding the whole area and I'm subtracting off this area. That's if I was using a Z table. Normal CDF is so much easier. So don't do this. I mean, you can, if you really like to type with a typewriter, you really want to dial with a rotary phone, then absolutely do this. Otherwise, use normal CDF. Just use normal CDF. Okay. I'm going to go away from this screen before I make somebody have an anxiety attack. All right. So this is just kind of like your little page here to show you what you're doing with greater than, or less than, and all of that. So if you're using less than, it's going to look like this. It's going to be, I'm going to draw this. So it would be like, so it'd be like A and B. So if B is my upper bound and I'm going lower than, that's for this. If A is my lower bound and I'm going greater than, it's going to look like this. This is for if I'm going in between A and B. So that would be the in between A and B. So this is a really good, like, just keep this for your rule of thumb to show you. And I'm going to get all of this. Uh-oh, I hope you're not, I'm going to leave it because some of you like my scribbles. So remember, it's normal CDF, lower bound, upper bound, mu, standard deviation. Just remember that that's the way that we put them in there. Okay. Are we all still breathing? Is everybody still alive? Did I lose anyone? Do I need to like do CPR or anything? Are we okay? I know CPR. I don't know that I could really help you through the computer screen, but you know.
The normal CDF, lower, upper, new, and then standard deviation, that's how we're supposed to input it into the calculator, correct?
Yes.
Okay, just double checking.
Yeah. And obviously, if you have a calculator like mine, it's going to give you that cute little screen what it tells you to put them. But I know not everybody has that. So I try to make sure to give you that this is what it looks like in the other calculators. And this is
Gotcha.
this is the way you would write it in your work on your test.
Okay.
Actually, I don't care if you wrote me your screen, like some people, and I'm absolutely okay with that. Some people will show me their screen and they'll just write, let me see here. They'll write this stuff and I'm okay with that also. If this is what your screen looks like, okay, you're still holding on. Good. At least you're still holding on. So, but so if you just wrote this screen, I'm okay with that also. That or this or this screen. I'm okay with either one of those. Writing it this way or what your screen says. As long as you show me what you've put in your calculator, because typos happen. I am typo queen over here. And every time I make a mistake where I get an answer that looks weird, I go back and check and see if I made a typo because that's usually what I did. Okay, so please don't cry, don't freak out. Deep breaths, deep breaths. Sometimes they have a probability and want us to find the number or the data value or the z-score that goes with that percentile. So maybe you're like, this person scored in the 96th percentile on the SAT, and you are nosy because I know I am, and you want to find out, wonder what score they scored on the SAT. And so you can work backwards from the percent to the data value. We can work backwards. So let's show you how to do that real quick. I got to turn my light on. I've got groceries coming. Hold on a second. Okay. They're going to deliver my groceries. I got to have my porch light on. All right. So we're going to give you another calculator function. It's okay. You're okay. Don't, try not to worry. I'm going to give you another calculator function for if we give you a percentile or a probability, how to find the data value that goes with it. All right. You can draw the normal curve and shade it if you like pretty pictures. And if you want to type with a manual typewriter, you can use your Z table. I don't recommend it, but you can. Or you can use this lovely function right here, inverse norm. It is, I believe it's right under, I know you're going to write that down in a second. It's right under normal CDF. Inverse norm.
So we're trying to find a value of a percent or a proportion.
So let's say I say that, hey, my IQ is in the 91st percentile, and you want to find out what IQ goes with that percentile. So we're working backwards. We're finding the data value that goes with the percent or the probability. Does that make sense?
Okay, thank you.
Yeah. Or you're finding the z-score that goes with it. Okay, I'm gonna pop to we okay to go to the next screen? All right. So I'm just moving away. Okay. So for example, the GRE, it's a test, standardized test. It is normally distributed. It has a mean of 1049. Whoa, mean of 1049 and a standard deviation of 189. We want to know what score a student got if they're in the 85th percentile. I want to know what score they got if they're in the 85th percentile. So I have a percentile or a probability, and I'm working backwards. So I'm going to use inverse norm. put my percentile in. Okay. This is going to give me, this is area to the left. This is the area to the left, just letting you know. That's the area to the left. So, I lost it.
Always the area to the left.
That's what that is. So when I show it on the calculator, I'm gonna have to explain something, but the not every calculator lets you choose left, right, or center. Mine does. But if yours does not let you choose, the default is area to the left. Always. But my calculator and some other calculators lets you choose if you're using left, right, or center. So mine does that. This one does not. I'm going to pretend mine doesn't. Okay. So the area to the left, then my mean is 1049. My standard deviation is 189. I'm going to write down what inverse norm does for us. My probability, mean, standard deviation. That's what I have here. So I'm going to write out the word probability for notes purposes, move this over a little bit. Oops. So when I say probability, I also mean proportion or percentile. They all mean the same thing. Probability, proportion, or percentile. Let me show you on the calculator. Okay. It's second vars, just like we were doing. Go down to inverse norm. So this asks me the area, which is the same thing as probability, percentile, proportion. Make sure you convert it. 85th percentile. My mean was 1049. And my standard deviation is 189. Okay. Most people's calculators do not have this left, center, or right. Most of them will not have that. It defaults to left. So I'm just going to leave left on there because everybody else's defaults to left.
Mine, I go and I click on number 3, the inverse norm, and I click, and then it just at the top of it, it shows me normal CDF, and then it shows lower, and then in the lower it has inverse norm, and then a parenthesis, and then upper.
Because you were already in the normal CDF thing, so it just inserted your inverse norm into your normal CDF. So go do second mode to get out of everything. So if you do second mode, it'll get you back to your main screen.
Okay.
Now do second vars and go to the third one.
Oh God. Okay, there it goes. I was like, what is happening?
All right. The fact that I knew exactly what was happening tells you how common it is.
Okay. Thank goodness. Thank you.
Okay, I'm going to put this back in here. All right. So what this is going to tell me is it's going to tell me what data value is at the point at 0.85. So go here. And it's going to tell me that it's at 1051.3. And I would probably just, because the GRE scores actually don't have decimals, I'm just going to put down 1051 because this is one that it's only whole numbers. So it round to the nearest one. 1051 is the nearest. If you just put 1051.3, I'm not going to be like, it doesn't score that way. Most people don't know how GREs score. So just
Did
whatever.
you do?
I
I'm
got
sorry.
1244
Yeah, I think you did the wrong problem.
because you did normal CDF in yours.
Oh, I did a different problem. It's because I was talking about normal CDF. Oh my gosh. Thank you.
I was like, oh my God, I'm not getting anything right.
Thank you. Okay, there we go. Is that right? Yeah. Oh, there we go. 1244.9. So 12, so I would say 1245. Yeah, thank you. Y'all are holding me accountable for my math. I love it. Told you have too much caffeine. All right. So this gives me the data value that goes with that. So I'm gonna draw the picture really quickly. So woo. So draw my picture, my 85th percentile, because remember the area under the curve is 100%. So this means that 85% of my curve is 85% is colored in right here. That area is 85%. So it's telling me what data value is right there. What is that data value? Whoa. I was looking for what is that data value? That's what we were looking for. What data value bounds that 85 percentile? That's what we were looking for. We're going to do another one. Okay. So this is saying, the interpretation of this is saying that a person that scores 1246 on the GRE, right? It should have been 1245 because they use the Z table. So don't even worry about it. They use the Z table. A person who scores 1246 on the GRE would rank in the 85th percentile. I'm going to show you how to use the Z table, and you're going to be like, I am never doing that. So I'm just letting you know. So, let's use the Z table. Let me go to the Z table. Okay. If you are using the Z table, I'm looking for the 85th percentile. The way that we do this, and you're going to be like, I don't ever want to do this, is I look in the body of the Z table and I find the number that is closest to the 85th percentile. So that would be this right here. So this, I look for the percent in the middle of all of this this field of percents. I look for 85%. So that's right here. This 0.8508 is closest. You're not going to get exact. So we find the closest one. That corresponds to a z-score of 1.04. So now I have a z-score of 1.04. Go back over here. So my z-score, 1.04. Remember the way that we calculate z-score is x minus mu over standard deviation. I need to find the data value. I need x. So here's what I'm going to do. Z equals x minus the standard, or the mean in this case was 189. Oops, sorry, it was 1049. I'm ignoring this. I don't like the way they do this. Divided by my standard deviation of 189. So now we're just going to math it out. I'm going to, oh, we have the z-score. I have the z-score. My z-score is 1.04. I'm going to multiply both sides by 189. 1956.56 equals x minus 1049. So now I'm going to add 1049 to both sides. I have an extra number in there. It was 19.56. 196.56. See, I can't even math correctly. Plus 1049. And I got 1245.56 equals x. See, I told you this is a lot of work. I don't recommend it. Don't use the Z table. Just use inverse norm in your calculator. I always have every single term. I have a purist that will only use the Z table. This is kind of why I go through this, because every term I have somebody that wants to use the Z table. I have to tell my daughter just a second. I'm supposed to watch my grandkids. She's like, what time are you picking them up? A little bit. Okay, anyway. All right. So don't use the Z table. Yes, I showed you how to use it. Use inverse norm. Inverse norm is your friend. Use inverse norm. Okay, moving on.
Were the slides you were just working on, I don't have that from the PowerPoint. Were they included?
It's because so this one right here had like a bunch of different stuff that landed on top of it. I just separated it into like 4 different slides. I took one slide and split it up because it had animations.
Oh.
And so I just split it into like 4 different slides because see, I also have one that I have the Z table plastered over top of. So it's all,
Oh,
this slide was just one slide right here. And then I just plastered other stuff onto it for just for show. Because you have this one, right?
yes, I have.
Okay. Yeah.
Oh.
So it's just the same slide over and over again. There we go. See, it's the same slide 4 times. Because I knew I was going to do math on it. Okay, let's do another one. The weights of giraffes are approximately normally distributed with a mean of 2,200 pounds and a standard deviation of 200 pounds. What would be the weight of a giraffe in the 75th percentile? So I want to, real quick, percentile means that what percent is less than or equal to that. That's what percentile means. It is already saying less than or equal to. So it's telling you this is to the left of. If it says percentile, it's what's to the left of. So it's already giving me that. So I'm going to use inverse norm. So we're going to do inverse norm. It's the 75th percentile, so it's going to be like this. My mean is 2,200 pounds. My standard deviation is 200 pounds. So I want to know, this is my 75th percentile. This 75%. If 75% is right there, I want to know what is this data value? What is that data value that bounds that 75th percentile? What value are 75% of the giraffes less than or equal to? That's what I'm wanting to know. Pop over here. So inverse norm, 0.75. My mean is 2,200. Standard deviation is 200. And most of you don't have that left, I'm sure. Yes, there you go. Y'all did it. Yay! Yeah. So it's about 2,334.9 pounds. Good job. Yay. I love when y'all type answers in the chat. I love that. It's like class participation, y'all. All right. Me and my weirdo sense. Okay.
Do you
We're
have an
yes.
explanation why the why that first one is called area? Like area, I know it's asking for the probability or the percentage.
Okay, so last on Tuesday, and it's okay if you didn't get that yet. So we talked about that the entire curve is 100%. It is the area under the entire curve is 1. So the area of the under the curve corresponds to the probability or the percent of the curve that is shaded. So this right here, whoa, that wasn't supposed to happen. So this right here, this part of my curve right here is 75% of the entire curve. It is, so the probability of something landing in that area is 75%, but is also the area of it is 0.75. I don't know how else to explain it. So
That makes perfect sense. It just and I did catch Tuesday's
okay.
class.
And
I just wasn't working in my head why is it saying area and not probability, but that's explains it.
Well, and plus it's been 2 days since Tuesday. So I totally get that. All right. Yes, that's why it says area. And you just kind of are like, okay, this is just the way the calculator is doing it. So we are going to talk about what happens when we are looking for something like this. We're looking for a range. And this right here is where people have problems. So I'm letting you know This is the sticking point in this lesson. Every single lesson seems to have a sticking point. This is the one. This is why we're gonna draw a picture. I highly recommend drawing a picture. Whenever you hit problems like this, draw a picture. And if I got $1 for every normal curve I draw, okay. So we know that the length of a certain steel rod is normally distributed with a mean of 100% or 100 centimeters and a standard deviation of 0.45 centimeters. They want to accept 90% of all rods manufactured. So they're going to throw away the smallest ones and the biggest ones. They're going to keep the ones that are closest to average, the 90% that are closest to average. So what we're looking for is the middle 90%. So I'm going to, it likes to switch away from the pen randomly. So I'm going to draw this right here. This is 90%. If it's the center 90%, that means that there's 5% down here and there's 5% up here. Hope I haven't lost anyone yet. Therefore, this spot right here, 0.05. This spot right here is 0.95. Because this is 5% of, whoa, that's not a highlighter. This is 5% of my area, and this all right here is 95% of my area. That's why I'm using 0.95 with this, 0.05 with that, and that's really ugly because it's highlighter, but I'm trying to get you to get the picture. If your fancy schmancy has that left, center, right, you can do this differently. But I'm going to do it as if it does not have that. I'm going to pretend we only have left, because most of you only have left. There may be one or two of you that has the left, center, right, but I always teach this as if that doesn't exist. So
What is this called? Like, what are we,
okay, so we're still doing the same thing, but I'm
okay.
for the center 90%. I want to know what data value lands me here. And I want to know what data value lands me here.
Okay.
So what I'm going to know is if the rods are smaller than this, I'm going to throw them out. Or if the rods are bigger than this, I'm going to throw them out. If that makes sense. Okay. So what I'm going to do is I'm going to use inverse norm with 0.05, 100 centimeters, 0.45 centimeters. And then I'm going to get a data value. I'm going to get that data value. Then I'm going to use inverse norm with 0.95, 100, 0.45. That's going to give me that data value. So we're going to be using inverse norm 2 times to get those 2 data values. The thing where people mess up is they don't get me to get to the center. They will just jump to using 0.90 with inverse norm and leave it at that. You need to make sure you are getting to the center. Okay, I'm going to give you a second and then we'll go to the other screen. Okay. All right, so in my calculator, second vars, inverse norm, I want to do 0.05 with the 100 centimeters and 0.045. This is going to give me that lower data value. So it's that lower data value. It's going to be 99.93 centimeters. This is not a percent. Remember, this is a data value. And I'm going to do inverse norm again. 0.95. enter, and then 100.07 centimeters. I'm going to give you a second, and then I'll go back to the other screen.
So the first one was the smaller data value
Yes,
of 99.
yes,
So that's a really small in between. Like,
yeah.
you-
Well, it has a standard deviation of 0.45. So if you think about how much, yeah, it does seem like it's not very much, but then you're like, okay, well, whatever these steel rods they are, clearly there's not much tolerance in whatever they're used for. So basically what we're going to say is they're going to keep all of the steel rods that are between 99.93 centimeters and 100.07 centimeters. So all of those steel rods between those two values, they're going to keep those. And they'll throw out anything below the 99.93 or above the 100 point. You got something different? Did I put typo wrong? Maybe I typoed. Can you look at, did you use 0.05? You got the same thing as I did. They're the same value.
oh, I got 99.25 now that I'm looking at it.
Really?
Yeah, that's what I got too.
Did I typo? Oh, I did. I put a 0 in there. Look at that. And so the other one's wrong too. Look, I have an extra 0.
Yeah, man. I wrote it all. No, it's okay.
I'm so sorry. There you go. Then I put an extra, let me fix this one too. You know, I told you, I'm typo queen. I am the typo queen. All the principles are still the same. Just the numbers are wrong. The principles are the same. Well, what would I do without you? This is the nice thing about this being after we've developed a rapport, is that you guys are no longer scared of me. You'll tell me when I make errors. So I'm so glad. Not that I was scary before. I don't think I was. Was I? Was I scary before? Okay. There we go. It's fixed now. So now is this the numbers you got? Okay, so 99.26. Yeah, thank you. So 99.26 and 100.74. There we go. So this is why if you show me your work, and if there's a baby typo, you only lose like a half a point. So because I'm the typo queen, I know how easy they are. So same principle still applies. They're going to throw out anything longer than 99.26 or shorter than 99.26 or longer than 100.74. So they toss all those out. So that's what this middle thing is. Let me see what's on the next screen. That's exactly the same thing. Okay, so they just showed the same picture. I'm going to show you real quick. We're going to jump to, why don't I have an extra page?
Can I just ask a really quick question?
Huh?
So if we do have the center, we
Uh-huh.
just put it in as if we're putting in the left, and then we just move that little cursor to the center, and it'll give us those two. And that's okay to use?
Okay. Oh, if you have center?
Mm-hmm.
Okay, if you have center. So if you don't have center, ignore this. Everybody ignore this if you don't have center on yours. So I have center on mine. If I have center on it, I can do 0.90 and then go down here to center. This is so you can just use the 90%. So I want the center 90% and then go down here and it's going to just give me both values. So see, you're the one of the one or two people. So if you do have that center on yours, then it's going to give you the range. It'll give you both the lower and the upper. So, and then the thing is if it gives you, if it wants greater than, if it wants you to do to the right of, if you don't have center, you need to do 1 minus. But if you do have center, then you can do right instead. If you do have the right, left, right, center. Okay.
Sorry. Can you do that one more time on the calculator?
With
Because I have
with center. Okay, so do second bar.
yes.
And it was asking for the middle 90%, right?
Mm-hmm.
You just put the 90 in here. This is only if you have the center button, people. So put
Uh-huh.
9 here, and then you tell it you want the center 90%.
Okay.
And then paste, and it will give you both the lower and the upper.
Okay. Thank you.
Okay.
So left is less than, right is greater than.
Right.
Is greater than, can it be written greater than or equal to the same as less than?
Yeah, it's exactly the same. Okay, I'm going to jump real quick to a couple of homework questions before we wrap things up because that was the last slide. So I'm going to jump to a couple homework questions real quick because I'm going to go to the ones that have the most errors. All of these are pretty easy. These aren't too bad. They give you all your things. The inverse norm ones are this one's not too bad because I'm just looking for between those. Just use this would be we're looking for z-scores. The things that this is where this isn't even that bad. Okay, this one right here, you would do 1 minus. If you don't have the center right and left, what you need to, you either do, you're not really, what you're going to do is if the shaded area up here is 0.25, you have to put 0.75 into your calculator for inverse norm. If you don't have right. If your calculator doesn't have right, you're going to put 0.75 because this is shading up here. This is where people struggle. Okay. I need to find a blank screen here.
Can you tell me what you mean by if your calculator doesn't have right?
Okay.
Because I have it.
So I'm going to get a new thing here. I'm going to draw this so I can show you. Okay. This right here is 0.25. Okay. So I'm looking for the z-score. Uh-oh. I want the z-score that's right here. This is what I'm looking for. Remember, our z-table and our calculators that don't say left, center, right show us, are giving us this right here. Okay? So if we have this, if we're looking for this, we have the area above the z-score. We have that area above the z-score, and I want to know what is the z-score right there. I have to use the z-score associated with 75%. So in your calculator, you'll do inverse norm 0.7501 because it's z-scores. So you need to think about if this area is 0.25, this area is 0.75. And then it just gave me an arrow. It did something weird all by itself. So you need to think about that. If, for example, a couple of you have the different thing, if you do this, it will do the same thing. But only if you have the right. Otherwise, you need to flip it.
I don't know why I looked at that problem and thought we would do normal CDF, but no, because we don't have a mean and standard deviation, but you
It-
should use it for.
Gives you an area because it's giving you an area.
Okay.
If it gives you an area, you're looking for a z-score. If it gives you, like up here, it gives me z-scores, I'm looking for the area. This is normal CDF right here. These right here are inverse norm because they're giving you areas.
Okay.
Okay, so this is what I want to talk about right here. And I'm going to once again draw it because I am the amazing artist, as you've all learned. Okay, this second here, I'm going to draw this picture and then, okay, 0.42. Okay, 0, 1, 1. Okay, my picture's so much better than theirs. It's not just so much better. All right. So they're giving me the middle 42%, correct? They're giving me a middle 42%. Remember, if you will, this is pretend that line goes straight through zero. This is the 50th percentile right here. That's the 50th percentile. Hopefully you're all with me still. So therefore, if this is the middle 42%, then I have 0.21 right here, and I have 0.21 right there on either side of my 0.50. I hope I haven't lost you yet. So this right here, 0.5 plus 0.21, so this is 0.71. This right here, 0.5 minus 0.21, 0.29.
Why are you doing 0.5?
Because this is my center. My center at the mean is the 0.5 mark. That's the 50%, like 50% of the data is below and 50% of the data is above. If I shaded below it, that would be 50% of my thing. This is the 50th percentile right there. That's why I did 0.5. And this drawing, it's centered on the 50th percentile right there. So I'm looking for the middle 42%. And maybe this will help. The middle 42%, 100 minus 42, is I have 68%, right? 58%. And I'm a math teacher. Okay. If I have 58%, if I divide that by 2, that means I have 29% down here, and I have 29% up here. Because I'm looking for the middle 42%. That's where this comes in, and this comes in. Okay. So you're going to use inverse norm 0.2901, inverse norm 0.7101. But I'm going to tell you a secret. These z-scores, because they're centered about the middle, these z-scores are going to be exactly the same, just opposites of each other. So if you found one, you found them both. I will show you. They're going to be opposites of each other because they're z-scores and they're centered around the mean. If you find one, you found them both. Just one's negative and one's positive. So you find one, you've got them both. So if you just do inverse norm with 0.29, then you have your negative one and then just make it positive on the other side. All right. Think I gave you enough to get you going. Absolutely send me messages. Please send me messages if you get stuck. I'm going to try to check frequently over this weekend while you're working on these. I want to make sure that I'm here to help you. So please, the more practice you do, the better you're going to get at this. Eventually, it's gonna come to you so quickly. And I know it's just this foreign concept right now, and some of you are kind of freaking out a little bit. But the more you practice, the better you're going to get, and you're going to get there. I have absolute faith in y'all. So you've got this. All right. Any more questions while we are on recording?
Do you feel like the quiz questions and the test questions are pretty similarly formatted to the practice on my open math?
The quiz deals with, I mean, it gives you some math, but it deals more with, do you understand what's happening here? More than, can you do the math? The quizzes are more like that. The homework are, I feel like the test follows the homework pretty well. I try to give more scenarios, like questions like essay, like this type of stuff more on the test because I like things applied. So you get more of like the steel rod problems, or they I want to throw away 2% shortest lifespan. I try to do more of the actual application problems on the test rather than as much of this stuff. I think there is one like this, but I try to do more applications on the test. Um, but otherwise, the math is all the same.
I know that the last test we had a lot of terminology that we needed to match and stuff. Is there gonna be, should we be going over all these terms and remembering exactly from 5 to 7? Because I think that I don't know because I can't go back and look at the test to see what I got wrong or not. But I felt I wasn't sure if I got
It doesn't let you see it because I thought I opened it for you to see it. Isn't, have you tried?
maybe I haven't tried since, but I will look into that.
So give it a shot. There's not going to be, it's not the beginning of the term had so much new vocabulary. It was pretty vocabulary heavy. This one is not as vocabulary heavy because you're thinking about like asking, is it a statistic or a parameter, or is it,
Yeah.
you're talking about that stuff. This one is not going to have as much of that. This one's more mathy.
Okay.
Because the you were the beginning, the first test, you were learning a new language. And now we're really into the nitty-gritty of the math and the analysis. So
Which completely threw me off because I was getting really good at the math and I was so unprepared for words. I was just like, wait.
yeah, this one is more mathy, less vocabulary-ish. Anyone else have any questions? I will post the recording. I have to go pick up my grandkids. I have to go pick up my grandkids, which will take me about 20 minutes or half an hour. And so I'll probably have it posted within an hour. See, my grandkids, I'm on recording. I'm going to get off here, even though people are going to be like, what are you going to talk about? I'm getting off of here, off the recording.